A load of mass 6 kilograms is held on the end of a string. Calculate the tension in the string when the load is raised with an acceleration of 3 meters per second squared. The load is lowered with an acceleration of 3 seconds per squared. The load is raised with a constant speed of 2 meters per second, and the load is raised with a deceleration of 3 meters per second. What's very, very important in a mechanics problem is that to draw a clear diagram, if appropriate. So, drawing a diagram, here's my block of 6 kilograms. Now, what forces are acting on the block? Well, we've got the tension of the string acting upwards, and we got the weight of the block acting downwards. And we're told that it has an acceleration upwards of 3 meters per second to the minus 2. Now, you must decide whether you're going to take upwards or downwards as positive. So, resolving forces using Newton's second law. So, Newton's second law says F is equal to ma. And we're going to take upwards as positive. And therefore, if we do that, resolving the forces, we're going to say that T minus 6g, T is acting upwards, 6g is acting downwards, so it's minus 6g, is going to be equal to mass, which is 6, times the acceleration, which is 3. And then we can just go ahead and solve that. So we've got T is minus 6g is equal to 6 times 3 is 18. T will be equal to 18 plus 6g. And taking g as 9.8 meters per second squared, we're going to have that T is equal to 76.8 newtons. Okay, B, the load is lowered with an acceleration of 3 meters per second. So we've got tension acting upwards and we've got the weight acting downwards. Now, it's being lowered, so it's going this way, and so we're going to have an acceleration of 3 meters per second squared. Now, there's two methods you can do this. One, taking positive as upwards. Let's do it that way first. So if positive is upwards, it will be T is upwards, downwards is 6g is equal to 6, and as the acceleration is acting downwards, we'd say minus 3. So we're going to get T minus 6g is equal to minus 18, and therefore T will be minus 18 plus 6g, which is 40.8 newtons. Now, you could instead take downwards as positive. If you do it that way, then you say 6g minus T is going to be equal to the mass, which is 6 times the acceleration. Now, the acceleration is acting the same way as positive, 6 times 3. Now, rearranging that, we're going to get 6g minus T is equal to 18, and therefore we're going to have that T is going to be 6g minus 18, which again will give you 40.8 newtons. Either method must give the same answer. C. We're now travelling at a constant velocity of 2 meters per second. Okay, so we T acting upwards and 6g. It was going upwards, so the acceleration is 0 meters per second squared. There's no acceleration because we've got a constant velocity of 2 meters per second. So using upwards as positive, because it's moving upwards, we're going to have T minus 6g is equal to 6 times the acceleration, which is in fact 0. So in fact, we're just going to have T minus 6g is equal to 0. If it's in constant velocity, then it's sort of in equilibrium. So we can say that T is equal to 6g, and 6g is going to be 58.8 newtons. In the final case, where we have a deceleration of minus 3 meters per second squared, but the object is moving upwards. Again, I'm going to take upwards as positive, so resolving, we're going to say that T minus 6g is going to be 6. Now, because we have a deceleration of 3 meters per second, then the acceleration acting upwards is minus 3 meters per second, because the acceleration is acting in the opposite direction, because it's decelerating. So we've got T minus 6G is equal to 6 times minus 3. So we're going to have T minus 6G is equal to minus 18. And therefore the tension will be minus 18 plus 6G, which is 40.8 newtons. So this has been a video to show how to find different tensions when we have different kinds of acceleration. I hope you've understood, and I thank you very much for watching.